Welcome to this video on area formulas. We will review how to calculate the area for several common shapes. Let's begin with the rectangle. What is the area formula for a rectangle? The area formula for a rectangle is base times height, or BH. What other shape has 4 right angles, just like a rectangle? A square also has 4 right angles. Since a square is a special type of rectangle, can we use the same area formula for both shapes? Yes, we can use the same area formula, base times height, for a square as well. Let's practice finding the area. For the rectangle, the base is 17 meters, and the height is 10 meters. For the square, each side is 14 centimeters. The area of the rectangle is 160 square meters. The area of the square is 144 square centimeters. Now, what happens if we cut a rectangle in half? What shape is made? If we cut a rectangle in half diagonally, we create 2 triangles. Cutting a rectangle in half creates 2 triangles. So, if the area of the rectangle is base times height, what happens to the area formula for the triangle? Each triangle is half the area of the original rectangle. If we cut a rectangle in half diagonally, we create 2 triangles with the original area formula of BH. Since the triangle is half of the rectangle, its area formula is base times height divided by 2. Let's practice the triangle area formula. The base is 12 centimeters and the height is 5 centimeters. Using the formula base times height divided by 2, we find that the area is 30 square centimeters. To summarize, the area formula for a rectangle is base times height. Since a square is a type of rectangle, its area formula is also base times height. The triangle is half of a rectangle, so its area formula is base times height divided by 2. The formulas are: the area of a rectangle is BH, and the area of a square is BH. The area of a triangle is base times height divided by 2. Next, let's look at the parallelogram. What happens if we slice off the slanted part on the ends of the parallelogram? If we move the triangular end piece to the opposite side, what shape does it form? When we rearrange the pieces of the parallelogram, it forms a rectangle. Since the parallelogram can be reformed into a rectangle, the area formulas are the same. The area formula for a parallelogram is base times height. Let's look at a parallelogram. What happens if we slice off the slanted parts on the ends? Imagine slicing and rearranging the slanted end piece. We move the sliced piece to the opposite end. The parallelogram now forms a rectangle. The parallelogram has been transformed into a rectangle by rearranging its parts. What will the area formula be now that it is a rectangle? The area formula for a parallelogram is base times height, or BH. Be careful though. The height has to be perpendicular from the base, just like the side of a rectangle. Remember, the height must form a right angle with the base. The height is the perpendicular distance between the base and the opposite side. The rhombus is just a parallelogram with all equal sides, so it also has BH for an area formula. Let's practice. Find the area of the parallelogram and the rhombus using the given dimensions. The area of the parallelogram is 27 square inches. The area of the rhombus is 10.8 square centimeters. Let's try something new with the parallelogram. Earlier you saw that you could use 2 trapezoids to make a parallelogram. Let's try something new with the parallelogram. We previously saw that 2 trapezoids could be used to form a parallelogram. Now that we know the area formula for a parallelogram, let's try to derive the formula for a trapezoid. Here's the shape we are working on, a trapezoid. If we duplicate and flip this trapezoid, we can place the 2 copies together to form a parallelogram, as shown here. When we divide the parallelogram in half to get the trapezoid, what happens to the area formula? This is the central question we will answer. Recall the area formula for a parallelogram is base times height, or BH. Since the trapezoid is half of the parallelogram, its area would seem to be quote, but now there is a problem. If we use the original base B, we are counting both the top and bottom segments of the trapezoid's base. What is wrong with how we define the base? We need to account for the split base. We'll call the top segment base 1 foot and the bottom segment base 2. By adding them, we get the original parallelogram base. The height remains the same, so there is no problem there. Replacing B with the sum of the 2 bases gives us the area formula for a trapezoid, the quantity of base 1 plus base 2 times height, all divided by 2. Let's practice finding the area of this trapezoid. The top base is 3 meters, the bottom base is 11 meters, and the height is 5 meters. Using the formula, We add 3 and 11 to get 14. We multiply this by the height, 5, to get 70. Finally, dividing by 2 gives us 35 square meters. Let's summarize the area formulas we have learned, starting with the area of a parallelogram, base times height, or BH. Next, the area of a rectangle is also BH. The area of a square is base times height, which can also be written as side squared. For the triangle, the area is half of base times height, or BH over 2 feet. The area of a right triangle is also BH over 2 feet. Similarly, the area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. The area of a trapezoid is the quantity of base 1 plus base 2 times height divided by 2. This is a summary of the area formulas we've covered, including the parallelogram, rectangle, square, triangle, and trapezoid. We have just one more shape left to cover. Let's go back to the triangle. Do you remember that reflecting a triangle can form a kite? This is what a kite looks like, formed from 2 triangles. Now we need to find the formula for the area of a kite. First, let's remember the area of a triangle formula. The area of a triangle is base times height divided by 2. A kite is made up of 2 triangles. Therefore, the area should be twice the area of 1 triangle. Since a kite is 2 triangles, we multiply the triangle area formula by 2, which simplifies the formula to just base times height. The formula simplifies because the 2 in the denominator of the triangle formula is canceled by multiplying by 2. Now we have a different problem. What are the base and height of a kite? The green line is the symmetry line, and the red line is half the other diagonal. Let's use kite vocabulary. The area formula is the symmetry line multiplied by half of the other diagonal. Let's practice. Find the area of this kite with a symmetry line of 10 feet and half the other diagonal equal to 2 feet. The area is the symmetry line, 10 feet times half the other diagonal, 2 feet, which equals 20 square feet. To summarize, the area of a kite is the length of the symmetry line multiplied by half the length of the other diagonal. This completes our summary of area formulas. We covered the parallelogram, rectangle, square, triangle, trapezoid, and kite. Let's summarize the area formulas we've learned. The area of a parallelogram is base times height, or BH. The area of a rectangle is also BH. The area of a triangle is half base times height, or BH over 2 feet. This is because a rectangle can be split into 2 triangles. The area of a trapezoid is also based on the triangle formula. Similarly, the area of a square is BH, or simply side squared, since base and height are equal. This also applies to other types of squares, regardless of their orientation. The area formula for a general quadrilateral is more complex. However, we can see how the area of a non-right-angled parallelogram still relates to quote 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 a quote oct me h. The same basic formula applies to various shapes derived from the rectangle, such as this variation of a parallelogram. Moving to the area of a parallelogram, it is still BH. This formula extends to other quadrilaterals like rhombuses. Finally, the area of a trapezoid is calculated using the formula base 1 plus base 2 times height divided by 2. This formula holds true for both isosceles and irregular trapezoids. We have covered the area formulas for parallelograms, rectangles, squares, triangles, rhombuses, and trapezoids in this video. Let's quickly recap the formulas. The area of a rectangle or square is base times height, BH. This also applies to parallelograms, which have an area of base times height. The area of a triangle is half base times height, or BH over 2 feet. For the trapezoid, the area is calculated using the formula base 1 plus base 2 times height divided by 2. The parallelogram's area is still base times height, and the rhombus follows the diagonal formula, which can also be expressed as BH. The area formula for the kite is half the product of the diagonals, which can also be viewed through its symmetry line and half of the other diagonal. Similarly, the area of a rhombus can be expressed as half the product of its diagonals. This concludes our final summary of area formulas. Make sure you have all the essential formulas written down for future reference.